Morning, ladies and gentlemen. Welcome to the video on match pairs t-test. Before we get started, let's get the sponsor read out of the way. Of course, Couch Potato brand snack foods. Couch Potato brand snack foods. Are you hungry? Well, we've got you covered in crumbs. Again, with the crumb thing, ladies and gentlemen, I don't quite understand it. I clearly see that these people are no marketing geniuses, but what I will say is they make a great snack. So anyway, moving on. So we have the match pairs t-test concept, and this actually is, well, matched pairs procedures is the last topic that we have to worry about for this year's AP exam. So kind of cool. We're nearing the end of the material and we'll begin review once we get there. Keep in mind that they did cut out chi-squared testing, and I think that's actually an important procedure to learn too. And after the AP, we might, and in fact, I'm planning that we will learn chi-squared testing. Anyway, let's get into what we're doing today. That is the matched pairs t-test. And we're going to introduce the matched pairs t-test by trying to solve this problem. So I'll read the situation. Having done poorly in history final exams in June, 7 students repeat the course in summer school and take another exam in August. If we consider these students representative of all students who might attend summer school, do these results provide evidence that the program is worthwhile? Right. So the important thing is to understand what question are we trying to answer, and we want to know, do these results provide evidence that the program is worthwhile? So did summer school lead to improvement in these students' grades? All right, well, here's the data that we have here. And right off the bat, it kind of looks like we have 2 samples of data, right? So you might be thinking 2 sample t-test because we have quantitative data and it looks like there are 2 sets. However, the important thing to understand is that each of these sets of data are being generated by the same people. So who did we randomly select, or who really is our sample? And really it's just one group of people. Okay, so this is not a 2 sample t-test because we didn't draw 2 independent samples of information. We chose one set of people, and it was those people that happened to generate both sets of data that we have here. Okay, so for that reason, this is one way of identifying the difference between a matched pairs t-test and a 2 sample t-test. So just a little side note, our sample is of one set people. It's not always going to be people, of course, but I'm just writing that note so you identify the fact that yes, there are 2 sets of numbers, but those 2 sets of numbers are being generated by one sample of, in this case, people. All right, now the question that we're trying to answer is, do these results provide evidence that the program is worthwhile? So really, I don't necessarily care what Thomas got in June, and I don't necessarily care what Thomas got in August. What I do care about is how much has Thomas improved between June and August, or how much has he, regressed. Okay. Same thing with Mike and Joseph and all of these people. I don't necessarily care what their score was in month A or month B. I care about, well, what's the difference in their score? Because their difference is what's going to help me understand if that person improved, or if that person stayed the same, or actually even went down and regressed. All right. So when we do a matched pairs t-test, we're actually interested in the difference between, set A of numbers and set B of numbers. So today we're gonna take the differences and we'll do it in the order of August minus June. I think it's always important to be very explicit about what order you're subtracting. You can do either way, but make it clear what direction you're subtracting because it makes a difference, of course. And these differences are 11, -6, 8, 2, -2, 9, and 0. All right. So that difference of 11 that we see from Thomas, that positive 11 means that Thomas improved by 11 points. Okay. That -6 that we see from Mike means that Mike actually went backwards. He regressed by 6 points, so on and so forth. So now I'm just trying to give you an understanding of the meaning of what a positive number means in this context and what a negative number means. So, because that's kind of important when we're taking the difference of two numbers. So a positive number means improvement. A negative number means you got worse. And of course, a 0 means no change. Now, once we take those differences, this is actually the set of data that I care about. I can completely, at this point, ignore the June scores and the August scores, again, because it doesn't really matter what these actual scores were individually. What matters is what's the difference between these two scores. So once I take the difference, this is all I'm paying attention to. This is the data I care about in a matched pairs t-test. Boom. All right, so let's go ahead and run the whole thing. The plan, of course, like I mentioned, this is a matched pairs t-test. In a matched pairs t-test, the parameter that we're interested in is typically called mu sub d. Now, d for difference, and what I'm talking about is, well, in this list of differences, I don't necessarily care about any individual difference. I care about, on average, what is the difference. And if the difference is a large positive number, then that might indicate to me that this summer school, in this case, is actually doing a good job. If the difference is a large negative number, then that might indicate to me that summer school is actually hurting. If it's a number near 0, then I might not have evidence that proves it's helping or hurting, right? So, but either way, that is the parameter of interest. I'm interested in the true average difference between scores. Oops. And again, specify here, this is a good place to specify that you're doing August minus June. Now, I just want you to realize that this is different than the parameter of, let's say, mu1 minus mu2. I'll erase this because this parameter doesn't apply in this case. But remember, when we did a 2-sample t-test, our parameter was mu1 minus mu2. And if you recall, this was the true difference in averages. Blah, 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 whatever the context was. But notice how these two descriptions are very similar, yet are not the same. So we have the true average difference, which is mu of d. So In the list of differences, what is the average of those differences? Whereas when we did a 2-sample t-test, the parameter was the true difference in averages. And this wording sounds similar, but it is different, and I will be looking for that if we ever are able to do an actual test again. But I can rest assured that on the AP exam, they will look for that subtle difference in language. Okay, so make sure that that we have the understanding of the difference between calling something the true difference in averages versus here in the match pairs t-test, the true average difference. Okay. Getting rid of all this because it does not apply. My null hypothesis is going to be that the average difference is equal to 0. So we're always going to assume that there is absolutely no effect that the process is having. So there's going to be no difference before and after. Now, if the program is worthwhile, then of course, since we're subtracting August minus June, we should see a positive average difference. And so that will be my alternative hypothesis. Okay. And notice that this looks very much like a one sample t-test. And in fact, that's how this procedure is going to go for the rest of the way. It's identical to a one sample t-test once you get the list of averages. That list of averages is essentially, you can think of it as just the one sample of data that you're interested in. All right, we're going to let alpha equal 0.05, and I'm just going to list my summary statistics too. So what is the average, the sample average of differences? And what is the standard deviation, the sample standard deviation of differences? And of course, to do that, I can use my calculator. And like magic, so of course I'd enter them into my list, but I've already done that. All right, that's called preparation, ladies and gentlemen. And I'm going to go to stat calc, 1var stats, list 1, calculate. All right, so the average difference, or the sample average difference is, hey, look, it's almost pi, not quite. 3.1429. Oops. And those units are, we could say points. And the standard sample standard deviation was 6.3358 points. All right, and that'll come in handy a little bit later on, these numbers. Let's go ahead and justify. By the way, once again, like when you're watching these videos, strongly recommend, playing them at like 1.5, 1.75 speed, because there's a lot of me writing and also me talking somewhat slowly, but play it at a faster speed, things sound a little bit better. So just a recommendation. Justify 1. Now, remember, this is usually where we see, was the sample chosen at random? Well, if you go back to the statement of the problem, there's no indication of that. However, there is this sentence that says, if we consider these students representative. And so that's all we need. So we're assuming we are assuming that the students are representative. Okay, so we're good to go there. And what are they representative of? Well, they're representative of all students who might attend summer school. And so basically the 10% conditions is asking The 10% condition should ask, is this number 7 less than 10% of students that would attend summer school? And let's just say that it is. I think it's not that far off, especially considering we don't necessarily know if this is one specific school or one entire school district. So we're going to say that 7 is less than 10% of students who attend summer school. Actually, back up here, I'm going to put the sample size, which is 7 students. And that means that our degrees of freedom, this will come in handy a little bit later, is just going to be 6. So like I said earlier, once we just get our single list of differences, this is treated just like a one sample t-test. And so our degrees of freedom is just n minus 1. Okay, back to the justification. This is now the nearly normal condition. So n is not greater than 30, so we need to check the normal probability plot. All right, so again, I have my data in list 1. I'm going to second stat plot. Let me just make sure that I have the normal probability selected, and I do. It's pointing to list 1, and it's on, so let's check it out. Zoom 9. And we have a normal probability plot that is approximately linear, and therefore the nearly normal condition is met. So we would say that the normal probability plot is nearly linear. Therefore, the differences, right? So that's, again, what we're studying is the list of differences or the distribution of differences. So we can say therefore the differences are nearly normal. Okay, and one last thing, one last condition with this is we did need 2 sets of numbers in order to get our information, even though each set came from one sample of people. And so we have to make it clear that this information is paired data, and it has to be evident, like exactly how we're pairing the data. Like I didn't choose Thomas's June score and decide to pair it with Joseph's August score, right? There was a very clear pairing of each one of the June scores and each one of the August scores. And so we can say that this is paired data. And just be clear that we paired scores by student. Okay, so and remember in the 2 sample t-test, we had to make it very clear that the 2 sets of data were independent of one another. In this situation, it's not that. We want to make sure that these 2 sets of numbers are actually very dependent on each other, right? Thomas's June score and Thomas's August score are very closely related to one another because Thomas is generating both of those numbers, so on and so forth. All right, so there we have it. We have justified all the conditions, and now what does that mean? So since the conditions are met, that means our sampling distribution of sample average differences can be distributed using the t-distribution. Of course, as we mentioned earlier, our degrees of freedom are 6. We are assuming that the parameter, so the true average difference, is 0. And so that means the sampling distribution would be centered at 0. And our standard error would be, it should be sigma over radical n, but since I don't have sigma, I'm going to use S to approximate sigma. So 6.3358 over radical n, which is radical 7. And let's see, I should have, no, I didn't calculate this, but I'm just going to leave it like that. It doesn't matter. Actually, you know what? I'll calculate it real quick. Yes, this is going to be calculated off screen, but all I'm typing in is 6.3358 divided by radical 7, and this gives you 2.3947 approximately. All right, so we have the observed stat, which I listed before. That's the X bar D that we observed, and it was 3.1429. Then we have our test stat. So that's our T test statistic, and we do the observed minus the mean, which is 0, over the standard deviation, or in this case, we would say standard error since we're talking about a sampling distribution. And so the test stat is approximately 1.3124. Now the question is that test statistic in the rejection region? And we can determine that by, did I say let alpha equal 0.05? I did, okay. So we're going to calculate the p-value. The p-value in this case is just a probability that t is greater than 1.3124. I'm using greater than because that's what my alternative hypothesis calls for. I have mu of d greater than 0. And this p-value is approximately 0.1187. Okay, now we are ready to make a decision. All right, I'm not going to interpret the p-value here, but because you've seen many examples of that, I'm just going to go ahead and make the decision. And I'm going to say that, of course, I'm going to compare p-value to alpha. And since 0.1187 is greater than our alpha value of 0.05, we will fail to reject H null, which is kind of sad. So this is kind of now providing evidence that the summer school isn't really providing an effective change in these students. So we failed to reject H null, which means we do not have evidence to support the claim that, all right, I want to reword it using their words, that the program is worthwhile. Okay. We do not have evidence to support the claim that the program is worthwhile. Okay. And that's that. Again, I'm just skipping the interpretation of p-value because you've seen it so many times, and this is already kind of getting to be a long video. So I do want to show you, before we end, I do want to show you how to do this on the calculator. Okay. And the way you're going to do it is, of course, go to stat, scroll over to, we can input the data again. Our null hypothesis is that mu d is equal to 0. The data that we're going to be studying is from list 1, And the alternative hypothesis is that mu of d is greater than 0. Okay, and calculate. And here you have the test statistic and the p-value that we discussed in the problem. And there we have it. All right, ladies and gentlemen, I hope you enjoyed that. I will be available for SGI today and every day for the foreseeable future. I hope you have a great day. I hope everything is well. And please enjoy those Couch Potato brand snacks. All right, until next time. Bye.